Hi guys, so today I'll be explaining the chemistry week 10 AMS quiz. And it's really simple. There's past material from week 9 and there's some material from grade 9 because there's a file in all weeks called experimental techniques. It's 25 pages and you need to read through it. Please read through it, or you can just skim through it, okay? You need to know it because pretty much 80% of the quiz is about it, okay? So let me just start explaining the quiz. Okay, which of the following mixtures are best separated into its components using simple distillation? So simple distillation, it's a method that you can use to separate a pure liquid from a solution. Yani, whenever we have a solid and liquid, we can separate it using simple distillation, okay? One solid and one liquid, okay? So let's check the options. Water, alcohol, solution. So we separate that using simple distillation. No. Why? Because as we just said, they're both liquid, right? Because solid and liquid. Okay. Since they're both liquids, we can't separate it using simple distillation. We have to use another method called fractional distillation, which I'll explain in question number 2. So don't worry about it. Okay. And oil and water, can we separate that using a simple distillation? No. Why? Because again, they're in the same state, but also when we're using fractional distillation, we use it to separate two mixable, they mix together, two mixable liquids, okay? 2 or more. Okay, oil and water aren't mixable. We know that. If we have a cup and then we add oil to it, oil is going to be on the top because it's lighter than water. And if we want to separate this, we're going to use something called a separating funnel, which is basically, it's like this, and then you have the oil and H2O here, and then you're going to add a cup on the bottom, and then here there's like a tap or like a switch, okay? So whenever we flip the switch, water falls down, and we have to stop the switch before oil comes in the cup, okay? That's how you separate oil and water. So not simple distillation. Okay, sugar, salt and water, no, because as we just said, 1 solid and 1 liquid, not 5 solids and 15 liquids, okay? Just 1 and 1. So that's wrong. And then sugar and alcohol, oh my god. Sorry, okay, so what was this? No. Okay, sugar and alcohol solution, yeah, because as we just said, solid and liquid, so that's correct. And then sodium chloride aqueous solution, yeah, because NaCl is a salt, and then if you add it to water, you get an aqueous solution, and you can separate it using simple distillation. So that's correct. So these two. Which of following mixtures are best separated into its components using fractional distillation? So as I wanted to say, fractional distillation, it's a method that you can use to separate 2 or more miscible or mixable liquids with close boiling points, okay? So 2 or more liquids, okay? And they're mixable. Let's check the options. Water and alcohol, yeah, because they're both liquids and they have close boiling points. Sodium chloride aqueous solution, that's wrong. Because we can use it to we can separate it using simple distillation, okay? Because it's solid and liquid. And then here sugar, no, once you see a solid, it's wrong because 2 or more liquids. And then oil and water, as we just said, fractional distillation is used to separate 2 or more mixable liquids. Oil and water aren't mixable, so that's wrong. And I know it says select all that apply, but you can only select one answer. So next, okay, a mixture of miscible liquids having close boiling points is to be separated into its components. Which of the following techniques should be used? We literally just spoke about it in the previous question, fractional distillation. Okay, a mixture of amino acids is a colorless solution. However, the mixture can be separated and analyzed using chromatography. I'm just gonna do a really simple, quick explanation of what chromatography is. It's like when you use it. Okay, look. We're learning about paper chromatography. Okay, so it's like whenever we have a small sheet of paper, and then we add a cup, and then we use any like solvent, and we use a solvent, okay, مثلا like H2O or something, okay, like water, okay, and then we're gonna add like ink here, and then when the water reaches the ink and then like goes up even more, it's gonna separate it into its components. Like for example, like maybe this is like black ink, so it's gonna be like yellow, orange, and green, and whatever. But here they're using amino acids. We know that amino acids are colorless, as they just said, okay. So how can we identify the amino acids? We can use something called locating agents, locating agents, and we can like spray them on. And we can also use UV light, like UV or locating agent, okay. So let's check the options. Exposing paper to infrared radiations, no. UV radiations. So UV radiations. Spraying the spots with locating agent that acts differently with the components of the mixture. Yep. Spraying the spots with special dyes, no. We only spray locating agents. Adding purple solution, no. We only add locating agent, or we can expose the paper to UV radiations. Which of the following are true about a compound? Okay, so a compound is a substance made of two or more elements which are chemically combined together. An example is like H2O. Okay, so let's check the options. Is it a collection of at least two or more substances? Yep. Not chemically combined together? So no, بالعكس, it is chemically combined together, so this is wrong. Wood is a compound? No, it's not a compound. It's wrong. Is there like a chemical formula for wood? No. Calcium carbonate is a compound. That's true. CaCO3. It is a compound because it's made up of two or more elements, Ca and C and O, chemically combined together. And so this is correct. Okay, it is a substance that cannot be split into simpler substances by chemical. No, that's wrong. You can separate it. So that's wrong. It is made of two or more elements that are chemically combined together. Yep. Okay, so it's these two answers. Okay, which of the following can be separated using filtration? Filtration, we took that last year. It's really, really simple. So it's just like, and here we have like a filter, like a funnel, and we add filter paper to it. Filter paper. Okay, and then we need a conical flask. Okay, and we just like add the solution. Let's say like I'm adding sand and water. If we're adding that to and using filtration to filter it, to separate it into its components, obviously we know that the sand is gonna stick to the filter paper. So like, let's say this is the sand, and then the water is gonna keep dripping, okay, until it fills the whole thing. Okay, so that's how we use filtration. So obviously we're gonna need insoluble solid and a liquid. We can't use filtration to separate salt and water. Why? Because salt dissolves in water. Okay, so we need an insoluble salt and a liquid. Insoluble solid and a liquid. Okay, so now let's check the options. So sand and water, that is correct. Why? Because sand is an insoluble solid and water is a liquid. Sand and salt, no, because we need an insoluble solid and a liquid, so that's wrong. Oil and water, no. Okay, an insoluble solid from liquids, that is correct. Homogeneous mixtures, no. Like if you saw it with your eyes, you can't know that it's like made of two compounds or something. Okay, like with salt and water, H2O. If you like dissolve salt in water, you can't look with your eyes and then say, oh yeah, that has salt. No, you're gonna need like a microscope or something, right? You can't just like see it with your eyes because it's homogeneous. However, heterogeneous, you can see that it's like not one complete compound or not one complete like thing, if that makes sense. So if there was an option that has heterogeneous mixtures for filtration, it would be correct. So the only answers are these two. Okay, examples of mixtures include. What does a mixture mean? it's like a compound, but the only difference is that the compounds aren't chemically combined together. Like, remember when we talked about a compound, we just tried the definition. Okay, so a compound is a substance made up of two or more elements that are chemically combined together. Like, you can't separate it. You're gonna need like some kind of like method, okay? But a mixture, it's a collection of at least two or more elements and compounds that are not chemically combined together. So that's the main difference. Here in compounds they are chemically combined together, but in mixtures they're not chemically combined together, okay? So if we check the options, here water, we know that water is a compound, calcium chloride is a compound, but steel, it's like an alloy, right? Remember we took it last year? An alloy, yani it's a mixture of two or more metals. It's a mixture, they're not chemically combined together. And another one, paper. It's not imagine like paper had like a chemical what's it called, formula? No, there's no. But like for helium there is He, hydrogen H, and here there's CaCl, here H2O. Steel doesn't have a chemical formula. Okay, ethanol. Okay. Here it's really easy. Look, ethanol, it's flammable. Okay, I'm not gonna write that. Flammable. Yani if it comes into contact with like a flame or fire, it's gonna boom, like an explosion. Okay, so you're gonna have to heat it electrically. Here, electric heater. Okay, here a scientist found a chemical with no tag on it in his lab. To determine its nature, he should measure its boiling point and melting point. Why? Because each and every compound has its own and specific melting and boiling point. Like for example, we know that H2O boils at exactly 100 degrees Celsius, right? And we know that it melts at exactly 0.0 degrees Celsius, right? Okay? Here sharply at those temperatures. And if you saw a compound or whatever that boils at 102 degrees Celsius, then خلاص, you can just say no, it's not a compound, it's not H2O. Why? Because even if there's like a slight difference, then it's not H2O. And I'm gonna write something that they might ask you about it. Just like give me like a sec, I'm gonna write it really quickly. Okay, so pure substances have sharp fixed melting point and boiling points. As you just said, H2O boils at exactly 100 degrees Celsius and melts exactly at 0 degrees Celsius, and an impure solid will have a melting point lower than the pure solid. Yani if you have an impure solid and we melt it, it's gonna be like lower than 0, yani -3 or -15 degrees Celsius, okay? And an impure liquid will have a higher boiling point than the pure liquid. Yani it's gonna boil at like 102 or 115 or something, okay? Okay, so next question. At any temperature, a solution is said to be neutral when OH is equal to H2, H plus. Okay? Easy. Okay, so to calculate the pH of a solution containing 1.0 times 10 to the power of -2 molarity of HCl. Okay, so first thing, we're gonna look at the compound or whatever they give you, like the compound, the compound. So first we're gonna check, does it have H or OH or both? Here it has an H, right? So, and then the second thing, we're gonna check how many H's or OH's are there. So how many? Okay, and then the third thing we're gonna do is we're gonna multiply the concentration that they gave us by the number of H's or OH's, okay? So, okay, again, so first thing, we can see that there's an OH, an H, okay? And how many H's are there? Is there a 2 or is there like a 5? Anywhere? No, it's just a 1. It's like 1, okay? So there's only one H. Now the third step, you're gonna multiply the concentration, which is 1.0 times 10 to the power of -2, by the number of H's. So there's only one. We're gonna get the same answer, so 1.0 times 10 to the power of -2. So that's the concentration of H plus. Now if we want to find the pH and they gave us the concentration of H, or we found it, what are we gonna do? We're gonna do negative log is equal to, or wait, no, there's gonna be a bracket. We're gonna put the concentration, so 10 to the power of negative 2, and then you're gonna put that on calculator, just like that, okay? But some calculators have like a box over here, so if your calculator has that, just like put a 10, okay? So if you put that on the calculator, you're gonna see that the answers, you're gonna get 2. So that's the pH of the compound, or whatever it is, HCl. So it's 2. And anything, look, here, like let's say this is the pH. Here's 7, the lowest is like 1, and the highest is like 14. Okay? So if it is lower than 7, then it is acidic. If it's higher than 7, then it's basic. And if it's at 7, then it's neutral. Okay? So next question. At the equivalence point, H plus is equal to OH. No, equivalence. Okay, so a student wants to obtain potassium nitrate crystals. They're gonna use crystallization, right? I'm gonna summarize what crystallization is. I don't know how to spell crystallization. Okay, just crystal like that. Okay, crystallization. So crystallization, you're gonna use this method to separate a salt or a sugar from a liquid, okay, and obtain the crystals at the end, like clearly from the word crystallization. So the first thing you're gonna do is you're gonna get your solution. Like let's say I have like NaCl and H2O. So this solution, I'm gonna put that in like get the evaporating dish and put the solution in it, and then we're just gonna like put like the Bunsen burner is like fire. I'm not an artist, okay, so just deal with it. Okay, so we're gonna put it on the Bunsen burner until most of the H2O gets, okay? The second thing we're gonna do after most of the H2 got evaporated, we're gonna remove this mixture and put it in the evaporating dish. We're gonna put it in a water bath. So I could say it's like my water bath, H2O bath. Then I have my NaCl over here, NaCl. Okay, then what am I gonna do after that? We're gonna heat that until all of the remaining H2O, مش احنا we said we're gonna leave some H2O when we're burning it with the Bunsen burner, so that it can, we left the H2O so that it can evaporate, like all of it can evaporate in the water bath. Okay, so that's the third step. And then the last step is gonna be that we're gonna just leave it to dry overnight, and we're not gonna put it in an oven, by the way. If we put it in an oven, we're gonna get powder. But if we want it to be like crystals, then we're just gonna leave it to like air dry in the sun or something. Okay, so those are the steps. So let's check the high. Okay, so the first step was to heat the solution on Bunsen burner until most of the solvent evaporates. The second step was to transfer the evaporating dish in a water bath, and then we're gonna heat it in the water bath. Heat it, and then we're gonna leave it to dry overnight. Okay, so which of the following shows the chromat of the dye that was separated into 3 components, A, B, and C, using paper chromatography in solvent X? So here they give us the length. So we have to choose the dye that's least soluble in solvent X. Least soluble, it's not gonna go like really far. It's gonna just stay really close to the solvent. The baseline. So the answer is gonna be C. And the equation for the RF value, look here, RF is equal to the distance traveled by the substance, in this case A, B, or C, over the distance traveled by the solvent. So here they want the RF value of component A. So where's component A? Here. It's 10 centimeters. So 10 centimeters over the distance traveled by solvent X. So 12. It's called the solvent front, okay? So 10 over 12, we're gonna get, it's 0.83. It's actually, it's like 0.83, like that. It's like 3. But they wanted two significant figures, so it's gonna be 0.83. So here's 0.83. Choose the correct answer to identify the nature of each of the given oxides. So we have 4 different types: acidic, basic, amphoteric, and neutral. Neutral, okay? These 2 are the ones I need to memorize, and these you can just know them from the periodic table. So when you have a acidic oxide, I'm gonna write O2, it's non-metal and O2. Okay? So like non-metal, what's any non-metal? Like CO2, okay? Basic is metal and O2. So like MgO, this one, okay? Amphoteric, we only have 3. So it's Al2O3, Zn, and PbO. Okay? And neutral, we have 4: H2O, N2O, CO, and NO. Okay? So acidic reacts only with bases. Basic reacts only with acids. Amphoteric reacts with both, and neutral reacts with none. Okay? So now that we have that in mind, we're just gonna check the question. So Mg is metal. So metal and oxygen is basic. CO2, C is non-metal, and C is non-metal. So non-metal and O we get acid. Okay, and then Cu is a metal. So Cu and O is basic. N2O, that was in the last column or last row. It's neutral. CO, neutral. ZNO, amphoteric. It was like you have to memorize the last 2, the amphoteric and neutral. SO2, it's acidic because S is non-metal and O non-metal and O. And Al2O3 is amphoteric. C is metal, so metal and oxides is basic. Okay, so a student wants to find the concentration of H+ ions and OH ions in a sample of 0.4 molarity of a strong acid H2A. So we're gonna follow the steps. So first step, we're gonna check if we have H or OH or both. Here we have an H. Okay. Here you have an H. Now we're gonna check how many. How many? Here we have 2. And now the last step, the number times the concentration that they gave us. Here they gave us 0.4, so we're gonna do 0.4 times 2. We're gonna get 0.8. So that's the concentration of H+. 0.8. Now here they want, here H+. So 0.8, and we're gonna make that in scientific notation. So 8.0 times 10 to the power of negative 1. And then if we want to find the OH, we're gonna use the KW formula. So if we have H, which is 0.8, we're gonna use the KW formula, which is equal to H+ times OH minus, so 10 to the power of negative 14 is equal to 0.8 times X, so So we're just going to put 0.8 to the other side, and we're going to get 10. The answer is 1.25 times 10 to the power of negative 14. Okay? So 1.25 times 10 to the power of negative 14. Okay, so I wrote the steps, and now we're gonna check if we have an H or an OH or both. We have only one OH, so 1 times the concentration that they gave us, so 0.06. So we have the concentration of OH minus is equal to 0.06. Now if you want to find the concentration of H plus, we're going to use the KW formula, which is equal to the concentration of OH minus times the concentration of H plus. So 10 to the power of negative 14 is equal to 0.06, no, that's 0.6 times x. We're going to put that to the other side, and we're going to get 1.7 times 10 to the power of negative 13. Again, it's 1.666, but we need to round it because it's two significant figures. So 1.7 times 10 to the power of negative 3. 1.7 times 10 to the power of negative 3. No, 13, my bad. 13. Okay, so a student is asked to find the pH of a solution in an experiment. He prepares an aqueous solution of a hydrochloric acid by dissolving 0.08 moles of the acid in 250 milliliters volumetric flask, filled up to the calibration mark at 25 degrees Celsius. Calculate the concentration of H plus ions. So here they want us to find the concentration of H plus. Here we have the moles and the volume. So how can we find the concentration? We're gonna do the formula NCV. Okay. So we're gonna put the number of moles over the volume, which is always in decimeter cubed. So if we have in milliliters, we're gonna change it into decimeters cubed by dividing by 1000. So 0.25 decimeters cubed. That's the volume. So 0.08 over 0.25, and we're gonna get the concentration of H plus. So put that in the calculator. 5. We're gonna get 0.32. That is the concentration of H plus. It's equal to 0.32. So 0.32, and since they wanted the three significant figures, we're just gonna add a 0. Okay, reduce the pH. So again, we're gonna do negative log, and then if you have a box here, just put 10, and then bracket the concentration of H plus, so 0.32, 0.4948, and it's really long. They wanted three significant 3 decimal places, 3 numbers after the decimal. So 1, 2, 3 here. Now this is above 5, so we're gonna add 1, so 0.495. That's the pH. 0.495. Decantation. Used to separate liquids that form 2 distinct layers. Because remember, I explained this using oil and water, right? So 2 distinct layers, you don't mix, right? They're immiscible, immixable, or not mixable, okay? So they form 2 distinct layers. Last question. Okay, so at point X, the number of moles of H plus added is, okay, look here, it's just like a straight line, so it's equal, right? So it is equal to the number of OH present, and the pH changes drastically. Why? Because look, it was 14, and then it became 2. Look, it used to be 14, or like around 14, so like 13, and then it went to E and it went to 2. So it was basic and it became acidic. So it drastically changed. Bismillah, inshallah, no mistakes. Okay, so thank you guys for watching. I hope you guys understood, and good luck on your AMS next week.